In the second part of Precalculus Lesson 19, we return to graphing logarithmic functions, and we will also look at the inverse of logarithmic functions. This is from section 4.4 in the College Algebra textbook. Let's start by graphing f of x equals negative log to the base 4 of x plus 2 minus 3. The first thing I want to do here is graph y equals log to the base 4 of x, which is our parent function in this case. And I will change y equals log to the base 4 of x into its exponential form of x equals 4 raised to the power of y. We've graphed similar functions here. We start with the y coordinates of -1, 0, and 1. Plug y into x equals 4 raised to the power of y to get corresponding x coordinates. And from there, we will plot the 3 points on our graph. 1/4, -1, 1, 0, and 4, 1. Then connect these 3 points with a nice smooth logarithmic curve, noting that the domain is 0 to infinity, the range is all real numbers, the asymptote is x equals 0, and we have the point 1, 0 on our graph. Now we're going to start doing some transformations until we have graphed f of x. The first transformation, I look at the input to my log, which would be x plus 2, telling me that I want to shift the graph of y equals log to the base 4 of x to the left by 2 units. And once we do that, we will have a graph of y equals log to the base 4 of x plus 2. Okay, so the next thing, seeing this negative out in front of the log, I will reflect the graph of y equals log to the base 4 of x plus 2 about the x-axis to give me this graph, y equals negative log to the base 4 of x plus 2. And keep this graph in mind. We're actually going to return to this in a little bit. Now, to finish off the graph of f of x, note the -3 here, and that tells me that from y equals negative log to the base 4 of x plus 2, I want to shift this graph down by 3 units, and finally we have the graph of y equals f of x here. The next thing we're going to do is find the inverse of the function that we just graphed. Y equals f of x equals negative log to the base 4 of x plus 2 minus 3. So to find the inverse of f of x, we would first of all swap the x and the y here so that we have x equals negative log to the base 4 of y plus 2 minus 3. And remember, I'm trying to isolate y here, so I'm going to next add 3 to each side. The left side is now x plus 3. The right side of the equation is negative log to the base 4 of y plus 2. I will multiply both sides of the equation by -1 to get negative x minus 3 equals log to the base 4 of y plus 2. And now the next step here would be to change into exponential form. So 4 raised to the power of negative x minus 3 is equal to y plus 2. And then we can finish off by subtracting 2 from each side. We've now isolated y, and y is equal to 4 raised to the power of negative x minus 3 minus 2. So the only last step here would be to rename y as f inverse of x, and we have our inverse function. F inverse of x equals 4 raised to the negative x minus 3 minus 2. To test graphically that this works, here's our original function, which we graphed a bit earlier. Y equals f of x equals negative log to the base 4 of x plus 2 minus 3. And if we graph alongside this, the graph of the inverse function, which is 4 raised to the negative x minus 3 minus 2, we can see the graphs of these two functions are indeed symmetric about the line y equals x. Let's move on to determining the solution to g of x is greater than 0 for g of x equals negative log to the base 4 of x plus 2. And this is indeed the graph that we had earlier that I told you to keep in mind. And what we're going to do before we get to that graph, though, is we're going to find the x-intercept of g of x, which I will find by setting y equal to 0, or in this case, setting g of x equal to 0. We have 0 equals negative log to the base 4 of x plus 2. I can multiply each side of this equation by negative 1. Well, negative 1 times 0 is 0. We have 0 equals log to the base 4 of x plus 2. Okay, and the next thing I want to do then is change into exponential form, which would be 4 raised to the 0 equals x plus 2. Okay, solving for x, well actually even before that, 4 raised to the power 0 is 1. 1 equals x plus 2. And now subtracting 2 from each side, we end up with x equals negative 1, telling me that I have an x-intercept of negative 1, 0. Which, looking at the graph here, will actually confirm that. You can see the point negative 1, 0 on the graph. And so from this graph, I get some other information too. Keep in mind when we graphed this function a bit earlier, we had the vertical asymptote, x equals negative 2. So really, all I need to do is keep this x-intercept in mind and pay a little bit of attention to the graph. The graph is, even though it looks like on these logarithmic graphs, it looks like we're like touching that vertical asymptote, we're really not. We're just getting super close to it. So I'm seeing that my graph, where my graph is above the x-axis, which is going to be where g of x is greater than 0, starts to the right of x equals negative 2. So from negative 2 to where we touch that x-axis at negative 1 at the x-intercept, not including negative 1, this is where my graph is going to be above the x-axis. This is also where g of x is greater than 0. So the solution here to this inequality is negative 2 to negative 1. Now, try on your own number 2. Find the inverse of the function f of x equals natural log of negative x minus 3 plus 4.